Hey folks, how's it going? This is Mr. Murray coming to you with a video on parabolas, okay? So over the past week, we spent a few days talking about some of the fundamentals behind parabolas. And so in this video, I'm going to talk to you about a few things: how to analyze parabolas of both types, how to graph the parabolas, including the focus, the directrix, the vertex, and two other points, and how to complete the square to turn a parabola equation from standard form, or expanded form rather, into standard form. So rather, we're going from expanded to standard, and the standard form are the equations you see here. Okay, so we started with the fundamental definition of a parabola, which is that given a line and a point not on the line, a parabola is the locus of all points that are the same distance or are equidistant from the point and the line. And remember, we said locus is just a funny way of saying, or a fancy way of saying set, and equidistant, right, means the same distance. And so this is what we call our focus, our point, and the line is called the directrix. Okay, so we have a directrix, a focus. Okay, so we talked about two different formulas for the parabola equation, right? When it's up or down, we have this kind of form. When it's left or right, we have this kind of form. And a few things we talked about in this form were, one, the h and the k. What are the h and the k? So the h and the k mean the same thing with parabolas they've always meant: the x of the vertex, the y of the vertex. This unit, we introduced a new thing called p, and what p essentially tells us is the distance from the vertex to the focus and the distance from the vertex to the directrix. So that distance is always going to be p. And the same thing goes here. If I go straight across to my vertex, that's going to be a distance of p. If I go straight across the directrix, that distance is going to be p. All right, in class, we tried to derive where it came from, and that was definitely a difficult lesson, but that's an important thing to know. Now, in class, we also talked about a bunch of formulas for how you find the equations of the focus and the directrix. I'm not going to go into that so much in this video, because what matters most is being able to find the vertex and then being able to intuit where the focus and the directrix are based on the value of p. Okay, if you know the formulas, it helps, but I think it's also kind of easier in a sense to go off the value of p. Okay, and so what we have here is, remember, when x is being squared, you look to the thing that's being squared. When the x stuff is being squared, we're looking at up and down. When the y stuff is being squared, we're looking at left and right. And remember, when p is positive versus negative, that affects the directionality of it. So for example, here p is positive because we're a happy face. If p was negative, we'd be a sad face, okay? The focus would be on the other side of the directrix, sad face. Here, if p is more than 0, this is this case, and I know that because we're pointing to the right, positive right. And if p was negative, we'd have the focus on the other side. We'd be pointing to the left. Okay? All right, so again, in this video, three things we're going to do. We're going to talk about analyzing a function in this form, or an equation, I guess I should say. 2, we're going to talk about graphing with the key points. 3, we're going to talk about completing the square. Okay, so let's go ahead and look at our first example here. So here, we need to graph the focus, the directrix, the vertex, and two other points. When I ask you to graph, generally, this is what I'm looking for. Now, folks, last year, Course 1 Honors, when we're graphing a parabola, typically I ask you for 5 points, including the vertex, right? 2 points on each side in the vertex. Here, the points are a little bit harder to generate. It's not just a matter of plugging in any number you want, right? There's a little bit more intuition and thinking through it. So in this case, you only have to graph 2 other points. If you can graph more than 2, go for it. Totally support that. Okay, so first thing we need to do is we need to look at our x and our y. We need to ask which one is being squared. Well, we can see that the 2 is here. The x minus 3 is being squared. So this is either going to be an up or a down parabola because it's the x that is being squared, not the y. Okay? And now I look at my coordinates. So the h is 3. Remember, we're trying to make this 0, right? That common theme. K is 2. So we have 3, 2 is our vertex. Now, here's our 4p. So we come over here. We know that 4p is equal to 4. Because if we come back and look at this formula, the thing in front of the y is 4p. So this is 4p is equal to 4. So we solve for p. We get p is equal to 1. Okay? Because p is 1, we're going to point up. Meaning, let's do our focus in blue. So our focus needs to be above. Sorry about that, got a little notification there. Focus needs to be above, and directrix needs to be below. I'll try my best to get this directrix as straight as I possibly can. Okay. Now, when I do that, and I get the directrix as straight as I possibly can, I note that the focus is 1 above, the directrix is 1 below. So this is the directrix, y is equal to 1, y equals, because it's a flat line. This is the focus, 3, 2, 3, 3. Okay, 3, 3. Notice x is the same, 1 above on the y. Beautiful. Okay, so here we go. We now need to get our 2 other points. So I got my focus, my directrix, my vertex, need the 2 other points. So in class, we talked about, let's take a look at this number right here, 4. So if I want my number to come out really nice and even and whole, I'm looking for a perfect square. I'm trying to make a perfect square because what I want to do is I want to subtract something, right? I want to square it. And I want, when I divide by 4, to get a whole number. Okay, so I got to think about what perfect square. And reminder, our perfect squares are 1, 4, 9, 16. That's 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. It goes on forever. But notice, let's go with a nice, easy number. So if we can get this to be 2, so that when I square it, I get 4. In other words, if we can get the whole left-hand side to be 4, when I divide by 4, I'm going to get a nice whole number. So let's see what that looks like. So what would I have to plug in for x so that I get 4, or rather I get 2 inside of here? I'm going to plug in 5, okay? So here's my x. And watch what happens when I plug in 5. So I get 5 minus 3 squared, right? Because remember, the points on the parabola, as with any function or equation, are the x's and y's that make the equation true. In other words, make both sides equal. So if I have 5 minus 3 here, it's going to give me 2. So I'm squaring the 2 because remember, PEMDAS would mean we're going to do our parentheses before our exponents. I square the 2, I get 4. And now, right, when I do that division step to get the y by itself, notice how it's a nice division. The division results in a whole number because I want to graph numbers that are whole numbers. I want x and y to be whole numbers because I don't want to be guesstimating here, okay? So I divide both sides by 4. This becomes a 1. And now look, all I have to do is add 2 and y equals 3. So look, x was 5, y was 3. So my first point on my graph, let's do, here's my x, here's my y, okay? 1, 2, 3, 4, 5, 1, 2, 3. Now observe that the focus is 2 away, the directrix is 2 away. So a couple students asked me in class, Mr. Moray, if I can count and see that this is 2 and that is 2, can I just plot the point? Yes, you may do that. But as you're going to see in this video, it's not always that easy, okay? A lot of times, it's not going to be that easy, especially when, if this is not a number that's evenly divisible by 4, meaning p is a fraction or a rational number, that's a fraction, it is not going to be as easy to get those points, okay? But if you can, personally, that's fine with me. But I would just appreciate if you could do some explanation if you're not going to do this work. Like, if you do this work, I see where the point comes from. If not, like, just please give me an explanation as to how did you get that? Where did that come from? So, like, oh, maybe do a thing 2, 2, okay? Now, remember with the parabola, we can save ourselves time because what I'm drawing here is our line of symmetry, x equals 3, right? And this is just whatever the x of the vertex is. And so what I know is that if 2 points, if their x values are the same distance away from this, their y values are going to be the same. In other words, 1, 2 will also work. Algebraically, I can see that because if I plug in 1 for x, let's see what happens. Do it in pink. 1 minus 3. I'm getting like a weird pink there. Sub it like that. 2, do a little bit of maroon. So say I plugged in 1. Well, what's going to happen here is I'm just going to get negative 2 squared equals 4y minus 2. And so look, it's just going to be 4. This is going to be the exact same problem, right? I'm going to divide by 4. I'm going to get 3. It's the same problem, okay? So that's the idea. You get your points, and then look, connect them. It doesn't have to be beautiful. Connect them. Okay, so I got the focus, the directrix, the vertex, 2 other points. Okay, so this was me going through this problem in really, really slow detail. I'm going to pick up the pace as I go just for the sake of the length of the video. If there was anything you didn't understand, I encourage you to go back and take a look at this, okay? And as always, feel free to send me questions if you have them. All right, so take a second if you need to, digest this, rewind this if needed, and then in a moment I'm going to move on. Alrighty, let's go ahead and move on to the next one. Focus, directrix, vertex, 2 other points. So I'm going to do this one a little bit faster. Now, as always, if you're in a point where you're very confident about these problems, you can feel free to pause the video. So I'm not going to do any explicit U-tries in this video, but I would encourage you to try any of them. I'd encourage you to pause any of the videos at any time at the beginning of the problem, try to graph it and see if we agree. Okay, so I'm going to do this rather quickly. So first we're going to see a square on the y, so I know it's either a left or a right parabola. Okay, it's going to be one of these two because the square is on the y. I'm going to start with a little analysis here. So I've got 8, and I've got my 2 and my 6. Now we got to be careful. The 6 is with the x, so the x of my vertex is negative 6. Don't jump too fast to read this because you want to make sure where x is the h, where y is the k. I also know that 4p is going to be equal to 8, meaning p is equal to 2. That's my distance. So let's hook it up. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2. There's my vertex. Now I'm pointing right. I know that because p is positive, meaning the focus is on this side of it, 2 units away. Rather, the directrix is. So that's a directrix with an equation of x equals 8. Rather, negative 8, 2 units away. Direct focus, okay? Focus is going to be a point of negative 4, 2. Remember, if I don't ask you to specifically give me the equation of the focus, rather the points or the equation of the directrix, you don't have to do that, but I do want to see it on the graph, and it needs to be clear what it is. So this is clearly x equals negative 8. This is clearly negative 4, 2. Okay? Notice, though, in this case, the y's are the same, okay, meaning they fall along the same horizontal line. Now I need my 2 points, so here I go. I'm looking at 8. I want a nice perfect square going into 8. I want to do 16. So what I'm going to do is I'm going to plug in 6 for y so that this becomes 4. So you're working smarter, not harder. Okay, so this becomes 4. So I square the 4 because PEMDAS. It's going to give me 16 equals 8 times x plus 6. 2 equals x plus 6. You divide them. X equals -4. So x is -4. Y is 6. So I come over. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Notice 4 away from both. I'll do my symmetry. 1, 2, 3, 4. 1, 2, 3, 4. Okay, because now the axis of symmetry is this line right here. Folks, on a quiz or a test, you may 1000% graph the line of symmetry as long as I can see focus, directrix, vertex, 2 other points. You are more than welcome to graph the line of symmetry if it helps you. And then I graph the function. And I'm a little bit of a stickler. Ooh. I'm a little bit of a stickler when it comes to graphing that out. Sorry about that. I just hit new page instead. So I'm going to make that look a little nicer. All right. And there we go. We have the function more or less. Again, focus, directrix, vertex, 2 other points. Okay, so please make sure you understand how I did this one, and think about how you might want to do this. Again, you could have counted and counted, and then in a moment I will go on to the next one. All right, wow, here we go. Moving on. And now what I have is this function right here. So this one is not going to be a matter of counting because of the 6 right here. So let's take a look. Again, square on here, so it's an up and down. Let's look at the vertex. So here's the H because it's with the X. The K is with the Y. I've got 4P is 6. So P is 6 over 4, or 3/2, or 1.5. Okay, so let's go. We've got 1, 2, 3, 4, 1, 2, 3. Here's the vertex. Let's grab the focus. So the focus, it's a positive number, so I'm pointing up. Got a little too excited there. It's a positive number, so I'm pointing up. Got one of these, meaning focus is above, directrix is below. So it is 1.5 above focus, 1.5 below directrix. Okay, so this is y equals -4.5. Focus is, let's see, well, the x is going to be -4, and the y is going to be -1.5. Points. All right, I see that, again, we go back to my perfect squares. I want to get 36 here, because if I can get 36, it'll divide out nice, so I plug in 2 to get 6 in there. So I get 6 squared equals 6, y plus 3. 36 equals 6, y plus 3. 6 equals y plus 3. Y is equal to 3. So I plugged in 2 for x. I got 3 for y. 2, 3 has got to be a point on the line. Okay, so again, you're plugging in the x, you're plugging in the y, you're trying to make both of them equal to each other. Okay, 2, 3. Let's check that again. You plug in 2. 2 plus 4 is 6. 6 squared is 36. You plug in 3. 3 plus 3 is 6. 6 times 6 is 36. So 2, 3 checks. It makes both sides equal. Now I'm going to do symmetry. 1, 2, 3, 4, 5, 6 to get to the line of symmetry. 1, 2, 3, 4, 5, 6. Guys, do the buy one, get one. You're killing yourself if you plug in 2 points. You're like, look, you can. But why? If you can use the symmetry. I really, really emphasize this. Anyone who had me for course 1 honors, I really strongly emphasize that. Get the buy one, get one. Why are you, you can plug, again, you can plug in. But why do that to yourself when you've got that beautiful symmetry? Okay? Take advantage of that because very, very few functions have that beautiful symmetry to them. Okay? So again, I really encourage you, go back, make sure you understand everything that I just did. And then in a moment, I'm going to move on. Beautiful. Here we go. I'm moving on to this one right here. Wow. Okay. Another one. And let's take a look at what we got going on here. So here, I kind of tried to trick you. Squares on the y. So it's a left or a right. Okay. Vertex has got to be 3, -1. And 4p is equal to -2. So p is equal to -1/2. Oop. P is equal to -1/2. Okay, that means what we're looking at is we're looking at a leftward facing parabola because when p is negative, it faces the other way. Okay, so let's start with my vertex. 3, -1. Oh, that was 3, +1. Anyone counting up my mistakes? I made a couple, and you know what? That's all right. Mistakes are how we learn. Okay, now I need my focus and my directrix. So here's my focus. And here's my directrix. Okay, not a straight directrix, but the best I can do. So let's do out our formulas here. Focus is same y. X is going to be 2.5. Directrix, x is equal to, let's see, we need an x, it's going to be 3.5. Focus and directrix. Now let's do our vertex. We got that. 2 other points. So again, 2, very nice. I'm going to shoot for 4. I could shoot for 16 if I wanted to. The only thing about shooting for 16 is that you're going to take the risk that the other point's not going to be on there. But you know what? Let's go for it. So here we go. Remember, plugging in for y. Okay, so I've got -2, x minus 3 equals, I'm going to choose 3 to be my y. Because this will become 4. When I square it, I'll get 16. Okay, this becomes -2. X minus 3 is 16. X minus 3 then must be -8. So x must be equal to -5. Okay, now when p is a fraction, right, counting the distance is going to be more difficult. And remember, your only other option is to use the Pythagorean theorem or the distance formula in the coordinate plane, which you can do, technically is right, but it is a lot more difficult, I would argue, than plugging in points. Okay, so remember, we plugged in a y, and I always like to point to the letter that I plug in so I don't forget what I plugged in for, especially with the left to rights, because we're not used to plugging in for y. X is -5, y is +3. And again, we can see this. 3 plus 1 is 4. 4 squared is 16. -5 minus 3 is -8. -8 times -2 is 16. So 1, 2, 3, 4, 5. 1, 2, 3. Okay, now let's use the symmetry. 1, 2, 3, 4. Back to the line of symmetry where the vertex is. 1, 2, 3, 4. So that would be negative 5, 1, 2, 3, 4, negative 5. Now, if I plug in negative 5, observe how negative 5 plus 1 is negative 4. And when I square negative 4, I also get 16. Okay? Tricky part for me on the tablet is going to be how do I graph this, but that's all right. Oh, man, I got lucky there. Oh, let's go. That's great. I got really lucky there both times. All right. Now remember, your graph doesn't have to be perfect, but I want to see a good attempt. I don't want to see straight lines. It's not an absolute value. And that's more or less how we're going to do this one. All right. So again, make sure you understood every step that I just took there. If not, I encourage you to rewind. But then in a second, I am going to go ahead and move on. All righty. Now I'm going to do the second type of problem. Now, in the second type of problem, we were not actually in standard form. We were in expanded form. So just like the circle formula, and I encourage you to go back and take a look at the video on circles. If I believe I did make one. If not, remember what we did in class. We had to complete the square to turn it into a circle. Okay? And so here we're going to do the same thing. The trick is, look at what is squared. Here, there the x was squared. So my goal is to make it look like this. If the y was squared, I would make it look like the other one. So here we go. This one I got lucky and the things have been separated. So generally the first thing you're going to do is you're going to separate the x's and the y's. Okay? Based on what is squared. So you want to get the squared stuff on one side, the not squared stuff on the other side. So the x is squared here, so the x is on one side. Now, you always want this to be a positive 1. Because remember, completing the square when x is not positive 1, we don't do that. Well, we can, but we do not want to. And in this class, I'm going to either set it up somehow so that you can do it, or I wouldn't give you the problem, right? So there would be maybe like a GCF you'd have to divide out. X would be negative, x squared rather, and you'd want to move it over to the other side. Don't complete the square until the number is positive 1. I can't state that enough, okay? So now we're already ready to complete the square. We got separation, we got 1. So what I'm going to do is I'm going to complete the square. I'm going to take 10. I'm going to divide it by 2. I'm going to square it. So we got x squared plus 10x plus 25 equals 4y plus 24. Okay, so I factor the lefts. Factor out the GCF on the right. And now I'm in the standard form. Now I graph. So it's just one more step. It's getting it to look like it did before, then graphing it. Okay? So again, it's going to be an up or a down because it's the x that's being squared. So let's take a look. So the vertex is -5, -6. 4p is equal to 1, or 4p is equal to 4 rather, so p is equal to 1. P is positive, so it's an upward. So let's take a look at the initial situation. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. P is equal to 1. It's pointing up. So directrix is below. Focus is above. Next step, I want to divide by 4. I'm going to choose lots of choices I could do. It looks tight. Looks like it's on the edges. It's pretty tight. So I'm going to shoot to make it a 4. Remember, the bigger the perfect square, the more likely it's going to shoot off the graphs. Just be aware of that. So I'm going to choose -1 for my x. And you'll see why in a moment. Actually, I'm going to choose a different number. I don't like -1. I want to make it 2, right? So I'm going to make it -3, because -3 plus 5 is 2. Mine would have worked as well. It would have ended up being 16, and that would have worked. It's just no guarantee that it would have fit on the graph. So we get 2 squared equals 4 times y plus 6, which means 4 equals 4 times y plus 6, which means 1 equals y plus 6. So -5 is equal to y. Subtracting 5 on both sides. So that means -3 went in. Answer ended up being -5 for y. So here we go, -3, -1, 2, 3, 4, 5. Again, we could see that's 2 away from the focus and the directrix. In this case, you could have done that as well. I used the symmetry to get the other one, or plug in. And there I go. Okay, so make sure now you understood both things I did. 1, completing the square. 2, finding the focus, directrix, vertex, and 2 other points. I encourage you to rewind, take a stab at it if needed, and then in a moment I'll move on. Alrighty, so moving on. And here we go. X squared minus 2y plus 4x equals 8, right? And then in a moment, in the last one, you're going to see what happens when y is squared. So again, I look to what's squared, and it's x that is squared. So what I'm going to do is I'm going to isolate the x on one side and the y on the other side. So here, x is positive, so I don't want to move over x. What I want to do is I'm going to move over y. So I get x squared plus 4x equals 2y plus 8. Now I complete the square. So I divide this by 2, you get 2, and square 2 to get 4. When you add one thing to one side, right, so you're adding 4 on the left, you need to add 4 on the right to keep it balanced. So 4 plus 8 is 12. Here I factor to get x plus 2 squared. You need to get a square. If you don't get a square, that means something didn't go right. Either you didn't complete the square correctly or the factoring wasn't correct. And now here I am done. Okay, so here we got a vertex of -5, -6. Here I'm going to get a vertex of -2, -6. Now 4p is equal to 2. So p is equal to 2 over 4. Which is equal to 1/2. It's positive. So again, the parabola points up. So let's start with our vertex, -2, -1, 2, 3, 4, 5, 6. Okay. Focus points up. So focus is a half unit above. Directrix is a half unit below. Now, sometimes I might ask you to state the focus and the directrix. If I ask you to state it, you do need to state it. So the focus is -2, -5.5. 2, 3, 4, 5.5. Directrix is, it's not going to be a point, right? It's going to be an equation. It's going to be a line. Y, horizontal, equals, so what's the y values here? Well, they're negative. We can see it. 1, 2, 3, 4, 5, 6.5. All right, now for my graphing. I see a 2 here. So I'm going to pop a 2 in here because I want to get 4. 2 plus 2, again, my x. Because I'm thinking like we're taking a quiz or a test. We don't have all the time in the world. So we're going to want to think about fast plugins and using symmetry. Okay, so 2 plus 2 is 4. Yeah, we could have used 2 as well. Right? See how this works. So we're going to get 16 equals 2 times y plus 6. So 8 equals y plus 6. So y is equal to 2. Okay, let's double check this. So plug in 2. 2 plus 6 is 8. 8 times 2 is 16. Plug in 2, 4, 16. So what was our point? X was 2. Y was 2. Other possibility, I'll show you real quick. You plugged in 0. Okay, so this is what we'd get. So it'd be 4 equals 2 times y plus 6. So 2 equals y plus 6. So y equals negative 4. Okay, that would have been our other option. So it would give us 0, negative 4. Now, remember, that's not good for me because I want to see, I'm going to do 0, negative 4. But I want to see a point on each side. So you can't just do those points and call it a day. So this is technically a point. And then our other point that we had was 2, 2. But if you want to get those 2 points, cool. But this is not good because I need points on the other side. So either you've got to use symmetry to go over 2, or you have to use symmetry to go over 1, 2. Remember our vertex is negative 2. 1, 2, 3, 4. 1, 2, 3, 4. Gotta do one of the. You gotta have points C on both sides of the vertex. The more points you get, for what it's worth, the cleaner the parabola is gonna look. Okay. So again, please make sure you understand everything I did here, from the completing the square to the finding the vertex, calculating P, getting my points, graphing everything. In a second, I am going to move on to the final example. All right, last example here. Now we need to complete the square, but we got an issue here. This is a huge issue. I never want to see a number bigger than 1 in front of y. So we're going to have to think about this. Notice, just like with the circles that we've done in class, notice the greatest common factor of all the things. So first what I'm going to do is I'm going to divide everything by the GCF because I want to at least get this equal to negative 1. So notice that they're all divisible by 3. So this is allowed. This is not factoring. This is an equation. And an equation, you're allowed to divide both sides by anything you want, right? Because that keeps the equation balanced. So 9 divided by 3 is 3. Negative 3 divided by 3 is negative 1. 30 divided by 3 is 10. 3 divided by 3 is 1. Okay? Now let's go back. Now we just go back and we do the last step. So notice the y is squared. So this is going to indicate it's going to be a left-right. So I'm going to move. Let's move the y and the 10y over. So I'm going to add y squared. I'm going to subtract 10y. I'm going to add y squared. I'm going to subtract 10y. So I get 3x. And then how about we minus a 1 on both ends? So 3x minus 1 equals y squared minus 10y. All right, let's complete the square. So to complete the square, we divide 10 by 2, that's 5. Square 5, you get 25. So we get 3x plus 24. Okay, now we factor. Notice there will be a GCF. This is going to be tough because it's 3, but that's all right. This is going to be y minus, because it's a minus, 5 squared. Beautiful. Now again, perfect. The y is squared. We're going left and right. Let's check for the vertex and everything. So the vertex, here's the h, it's with x. Here's the k, it's with y. Beautiful. P. 4p equals 3. So P is going to equal 3/4. So again, we get not a whole number. The vertex is going to be, rather the focus and the directrix are going to be a little sticky here. So we're not really going to be counting to get the focus and the directrix and the other points. Well, not the focus and the directrix. We're not going to be counting to get the 2 other points that go with the vertex, because that's not going to do us a lot of good. So here's 8. I know because it goes to 10. 1, 2, 3, 4, 5. 8, 5. Okay. Now they're -8, 5. But that's the correct point. All right. P is 3/4. It's pointing right because P is positive. So more or less, we're going to go 3/4 of the way on this side. Okay. So we'd have X equals, so we're -8. We go 3/4 down. We're at -8.75, right? Almost -9. Focus, -7.25. 5. Again, the 5s keep it on the same horizontal line. Now we need to find our 2 points. So I'm seeing 3. I'm going to shoot for 9. Only one I can think of off the bat. So we need to make this 3. So I'm going to say, let's plug in 8. Because 8 minus 5 we know is 3. So 3 times x plus 8, that's 3. 3 times x plus 8 equals 9. X plus 8 equals 9. So x is equal to 1. Let's double check that. So when x is 1, 9 times 3, or rather, sorry. Yes, when x is 1, we get 9. 1 plus 8 is 9. 9 times 3 is 27. When we get, this is 1, let's just double check that. What's going on here? So again, we plug in the 8. 8 minus 5 is 3. 3 squared is 9. Here's what I didn't do right. Mr. Murray mistake. Divide, you should get 3. So this needs to be -5. Now let's check -5. This way you always check your work. -5 minus 8, -5 plus 8 is 3. 3 squared is 9. Okay, 8 minus 5 is 3. 3 squared is 9. Good. So x is -5. Y is 8. Let's go -5. 1, 2, 3, 4, 5. 8. 1, 2, 3, 4, 5, 6, 7, 8. Let's use symmetry. So we go down 1, 2, 3 to the vertex. 1, 2, 3 to the second point. Okay? We connect. We connect. All right? And that is how we get it. So folks, remember the big things we need to know. 1, we need to be able to look at a formula. We need to be able to look at the h and the k. We need to be able to get the vertex. That is always true regardless of what type we're dealing with. We need to be able to look at p. Whenever we have a number in front of the thing that is not squared, we need to be able to solve for p. And we need to know, first of all, is it up, is it down, and the precise distance. We need to be able to calculate the vertex, the focus, and the directrix, and the focus and the directrix coming from P. And then we need to use special numbers going for our perfect squares, right? And get them divisible by 4P to work smarter, not harder. Okay, so I hope you found this video to be informational. I know it was definitely on the longer end. And I definitely will put in some timestamps in the video to help you out. But keep working on it, all right? It's not easy, but remember, don't forget, You can do it. All right. Thanks for staying tuned. Feel free to like and subscribe for more videos, and have a wonderful day.